Hello students, I'm back with you to do part 3 of chapter 1. Okay, so let's see where we are. Let's just call up that same section that we were busy with. And there we are. That is where we ended off the last time. Here, speaking about the dimensional analysis. Now we will continue to the section called unit conversion. Okay. Right. What are we talking about? Okay. We say here, these scientists, they want to establish what the relationship is between certain quantities. Right. And for that, they normally end up developing what we call mathematical equations or formulae that can be used to do certain calculations, because that formula is normally showing what we would call the mathematical model of certain phenomena. So you can do calculations of force, of distance, of acceleration, and so on and so forth. Okay. Now, for this thing to be globally acceptable by scientists, it is best that the people in South Africa must be able to understand the people in Britain or in the US or in Germany or in China, wherever. Sometimes we know very often South African or other people, they would like things to be manufactured and they want the Chinese normally to do it. Not just because the Chinese are, as some people say, Chinese products are bad. No, it is because the Chinese people, they would actually manufacture according to your specification. So if you specify a bad quality thing, they will give you a bad quality thing. So we must try to specify a good quality thing and they will give us good quality products as well. That is why even people in the West, they still go to China to get things manufactured. But if you want them to do it, you must do your specification clearly. And for that, the scientists need to use a globally acceptable language of science. And for that, we speak about the SI units. All units, we try to use the SI units in our formulae. Okay. So if you find that you have a particular unit, say for example in Britain, the people are speaking about feet or yards or miles, it is better to have it for the formula to work out properly. It is important for those things to be in SI units. So we have to be able to convert from whatever other unit form to the SI units. And for us to be able to do that, normally we need, as we showed earlier also, we need, I think we did this example before, yes, yeah. Okay, we need to know what the conversion factor would be. So in this case here, we know 1 mile will be so many yards and 1 yard will be so many meters. So we can convert from miles to meters by considering these two conversions. And then if you want to know how many meters there are in 1 mile, then we'll start off 1 mile is 1760 yards, and 1 yard is so many meters. So we just multiply this here by so many to get the number of meters in 1 mile. Okay, so you can do your conversions, but you need the conversion factors for you to be able to do that. Okay, normally these conversion factors would be listed somewhere. We just need to Google them and find them, right? Whatever we need. Or sometimes in textbooks it might be shown, sometimes in the inside cover of calculators, and some calculators are actually designed in such a way that they would actually be doing the conversion for you, right? Yeah, depending. But those conversion factors are normally available for you if you need them. Okay. Normally what I would do, I'll never ask you people to memorize conversion factors. If I were to ask you to do a conversion, I will give you the conversion factor, and then you must make use of that to do your conversion. Okay, that is in some cases. In other cases, which I will speak about later, we expect you to know certain methods. Okay, so important, people, before you start using values or measurements in a calculation, ascertain the unit. Make sure whether it is SI or not, and if not, get it into SI units. Say, for example, the miles per hour, the SI unit for velocity is actually meters per second. So you'll have to convert from miles per hour to meters per second. In the metric system, you can actually have kilometers per hour as well, but that also is not the SI unit for speed or velocity. So you will have to convert that to meters per second. Okay. And then they say here, sometimes one needs to convert according to known notations. For example, you have the metric system or the decimal system. You have the scientific notation method and the engineering notation method. And you can convert to any of these methods. Right. So I'd like to speak about this one, the metric or the decimal system, the scientific notation method, and the engineering notation method. It is worth your while to know these things because this helps us. This helps us to get a value into an acceptable form. Sometimes if you have completed a calculation, to get it into an acceptable form as well. Understandable form in terms of SI units. Okay, so firstly, the metric system. When this thing was introduced here, then we were looking at the number system. You know, in the number system, as you would have learned at school, let's say here, you have a number. Look at this number here, 4321.456. Here's a decimal point. So these ones are here. Remember, that would be your units. That will be your tens. That will be your hundreds. And that will be your thousands. And if that's a decimal point, that will be a tenth of a unit. That will be a hundredth of a unit. And that would be a thousandth of a unit. These things you people would have done at primary school already. And the beautiful thing about this number system, the Arabic number system or the number system, how can I put it, the zero for Arabic people, the cipher, that was actually developed in India, if I remember correctly. But this is all, these numbers are actually based on the Arabic system. Just for a matter of interest, you people don't need to remember this. If I were to write this number in the Arabic number system, that would be what, oh, that looks ugly. Let's do it over again. That is your 4. That 3 would be that. Your 2 would be that. Your 1, it looks the same as our 1. There's your decimal point, and there's your 4 again. Can you see the similar nature between this and the 4? No, that 4 that we have over there also. There's 4 and the 5. That looks a bit different. And that there would be your 6. Just as a matter of interest to show you, you can see that 1 and 1 looks the same. That 2 and this 2, if you just see that one, if you turn that around about 90 degrees clockwise, you can see you get the 2 there. That 3 over there will also be there, that part of the 3. And that 4, okay, a bit different. But that will be the Arabic number that you people see there. You know, those things are not important, just as a matter of interest. So these numbers are actually from the Arabic system. And the beautiful thing about this thing is, about the system and why we use this thing internationally now, is the fact that these are, as I said, units, tens, hundreds, thousands. Can you see? Always a factor of 10. Right? And that's why we call it the decimal. Decimal, deca. Deca means 10. Right? Okay. So decimal system. Right? Okay. Yeah, let's just take that away. That's not so important. Let's just take that away. Yeah. Yeah. Okay, now let's continue. if you look at these things here in the unit set, obviously, if we speak about 1 or units, and then that number is multiplied by 10 to the 0. 10 to the 0 is 1. So 1 times 10 to the 0 will give us 1. This thing here would be 10 to the 1. So 2 times 10 to the 1. That means 2 times 10, 20. So that is 20. That's why 21. That is 300. That's 3 times 10 to the 2. 3 times 100, 300. 4 times 1,000. So it's thousands. Can you see the factors of 10? Right? 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. And if you go to the right of the decimal point, that will be 1/10 of a unit. 1 over 10, right? So 10 to the minus 1. And that will be 5 times 10 to the minus 2. Right? Or 5 divided by 100. And that will be 6 divided by 100. Okay, that is how we actually use numbers in school already. And this is effectively the decimal system. Or we also call it the metric system of numbers. Okay, so let's see these names. Again, what is written there? There's your number. Each one of them is given a particular prefix. Each one of these here, thousands, hundreds, tens, tenths, hundredths, and thousandths, they are given a prefix. Just this one, the unit is not given a prefix. We call that the standard form. It has no prefix. But all the others will be given a prefix. So you have heard of deci, for example, decimeters, deciliter, and so on and so forth. Right? Centi, milli, right? So there you can see that 10 to the minus 3 will be milli. Why 10 to the minus 3? It's 10 to the minus 3 times your standard form, and so on and so forth. Centi, centimeter, decimeter, millimeter, and so on and so forth. Right? Deca means 10 times. 100 times means hecto, and 1,000 times means kilo. Right? So you have a standard form. If you have, for example, you have grams and you have kilos, it will be kilograms. If you have meters and you have centi, then it will be centimeters. Right? And then these are what we call the multiplication factors. Right? These are the multiplication factors. But effectively, we have this here. We have the standard form, the one without the unit, and then times 10, you'll get deca. Times another 10 will give you hecto. That will be the symbol. And times another 10 will be kilo. Or the standard form divided by 10 will be deci. Divided by 100 will be centi. And the standard form divided by 1,000 will be milli. Okay, now all these things here, what you have in this table, is again summarized in this table so that we can actually see their names. These names that you have here, we have it over here. If you have your standard form, and then these are your prefixes, symbols of the prefixes, and those are the names of the prefixes, right? M for milli, small m, right? Centi, deci, da, deca, h, hecto, and k, kilo. Please note that they are lowercase. Sometimes you have uppercase letters as well. Okay, but these ones over here are all lowercase. Okay, and notice your standard form, normally, can you see there? It has no prefix. Okay, so what do we mean by standard form again? Remember, it's not SI unit, students. Standard form means you have that particular symbol or that unit without any of these prefixes. So for example, in meters, if this were meters, then you can have decimeters, centimeters, millimeters, decameters, hectometers, and kilometers. But here you only have meters. Say same for seconds, kiloseconds, milliseconds, so on and so forth. For length, for mass, you can't put kilogram in here because here is kilo. So what is your standard form? Your standard form will actually be the gram, G, right? That's your standard form. And then all these prefixes can be included to get it in different formats. Okay, you must now know which one is your SI unit, and then you can work further. Okay, if you want to convert, right? If you want to convert, now this is the important thing now. use this thing here. Those are your multiplication factors, and I expect you people to memorize this. Okay. When you want to convert from the standard form to any other metric notation, so in other words, if you have something in standard form, grams, for example, you have 20 grams, and you want to convert it to milligrams, right, to another one, right, that's what they mean. From standard form to another metric notation, that is the others here. You will have to divide by your multiplication factor. Right. So what did I say? If I were to have 20 grams, let's see there, 20 grams. And you want to convert it to milligrams. What do we have to do? We have to divide by the multiplication factor of milli. Right, so 20 grams, that would be equal to 20 divided by this. 10 to the minus 3. Right, and that effectively means 20 multiplied by 10 to the 3. So 20 grams would be equal to 2,000. 20,000, sorry, right? And this times 1,000, 20 times 1,000. Divided by 10 to the minus 3 means times 10 to the 3. Yeah? Confirm your mathematics, please. This will be milligrams. What I want you people to note here quickly to get a feel of the subject. Which one is bigger, a gram or a milligram? A gram or a milligram? A milligram is extremely small. There are 1,000 milligrams in 1 gram. Can you see that? So if you have 20 grams, you will have 20,000. And there we are. 20,000 milligrams in 20 grams. Please, people, don't make sure that you don't make mistakes. Sometimes people would have said here, this thing here divided by 10 to the 3. And then if you're going to get 20 grams, it doesn't make sense. Just think about it. Just look at this thing here. I'm going to erase this because this is definitely wrong. This one is correct here. But this one here, 20 grams, assuming we write this thing here, is equal to 20 multiplied, 20, let's just take that away, divided by, I said to go from standard form to another form. Just assuming we have this thing here, 10 to the minus 3, divided by 10 to the 3. What will this give us? 20 divided by 10 to the minus 3, that will give us 20 multiplied by 10 to the minus 3. And that would actually give us 0.002 milligrams. Now, is this correct? Can 20 grams be so many milligrams? A milligram is much smaller than a gram. So this is definitely not correct. Okay, that is definitely not correct. Scratch it out. Okay, make sure that you know, right? For milli is 10 to the minus 3, centi is 10 to the minus 2, hecto is 10 to the 2. So if you want to convert from standard form to any of the others, say to kilo, then you divide by that multiplication factor. Remember, a kilo is 10 to the 3 of the standard form. If you want to convert from another metric notation to the standard form, so in other words, if you have 20 grams, no, that is standard form. If you want to convert, let's say from, let's write here 22 milligrams, right? And you want to convert to standard form, right? You have 22 milligrams. Then what do they say there? Then you multiply by the conversion factor, because milli means times 10 to the that, right? So that would be equal to 22 times 10 to the minus 3. You can write the answer just like that, leave it like that there. 22 milligrams is 22 times 10 to the 3 grams. Or you can say there, it will be equal to 0.022. grams. Okay, so that will also be correct. And this makes sense now. Can you see here? 22 milligrams and 0.022 grams. A gram is definitely bigger than a milligram. So if you have so many milligrams, you must have a smaller amount of grams. Right? You must get a feel for the values to make sure that you don't make a mistake. And then the next one here, they say for converting in metric form, when converting from one metric notation to another metric notation. In other words, we have a with a prefix to another one with a prefix. Then, if you know what the conversion factor is between those two, you can do it immediately. But the safer way is first convert to standard form, and then from standard form to the next one. Say, for example, if you want to convert from deciohms to hectoohms, then first convert from deciohms to ohms. You see, from deciohms to ohms. So you multiply by that conversion factor. Once you have it in ohms, then you convert that answer to hectoohms by dividing by this conversion factor. Okay, right. Another way in which you can do it, remember this is how I actually did it at school when I was still younger. And I think it's worth your while knowing this if you don't want to use these conversion factors for metric systems. You write them down like this here. K, H, D, A, standard form, D, C, and M. And right, if you want to, for example, convert 22.5 centimeters to meters, you first write that down. Keep them like this. K, H, D. I say I've got these arrows in between. Let's just do it again. K, H, DA, right? And then you have standard form. I'll just write here. Sorry for my mouse writing. That's just standard form over there. Okay, and then you have the other one would be deci, centi, millimi. Right. So if you want to say you have a number 22.5 centimeters, which you want to convert to meters, what we do is that point over there means on the left will be centimeters and that will be less, right? So that decimal now must be at centimeters. So that's centimeter over there, right? So I put my decimal there. First to put the decimal in its place, then I can write 22. Right? Okay, 22.5. That will be 22.5 centimeters. Can you see what I did? I first took, if I look at the unit, centimeters, then I put my decimal at the centi. And then whatever is on the left, I can write it down like that. Units of centimeters and tens of centimeters. Right. Okay. And then that is a 5. And if they say they convert it to meters, then what you do is you are going to move that decimal until it comes to meters. So what do? We shift it to the left once, twice. Right. So my dot must now come here. Right, to get it into standard form. Meters will be the standard form of this particular thing over here, meters, without any prefix. Right, so now I can see that 22 is there, the 2 is there, I can write it there, a 2 there, and I can write the 5 there as well. Just make it look nice. But seeing that the decimal is here, then we put a 0 here. That 0, we call it a placeholder. Right, so 22.5 centimeter will be 0.225 meters. Right, take another one here. Convert 16.2 meters to decimeters. So again, can you see the dot is, we say we have meters, so the dot must be at meters. Standard form, there's my dot. See that? Then the 6 and the 1, and then the 2 is on the other side. There we are, at the deci. You want to write this thing in decimeters, so that means I must shift this dot to deci. Right? I shift it to the right once. Right? I shifted to the right one, so there we are. There's my dot over there. So 16.2 16.2 meters would be equal to 162 decimeters. Okay, that is one way in which you can actually do it. The other way is to do it like this here. Okay, by knowing your multiplication factors. Please, people, I would like you people to memorize this. This we don't give to you in a formula sheet. Right? You people need to know them. Okay. Right. The next thing I can speak to you, remember that was decimal system or the metric system. Right. Let's continue speaking about scientific notation. What is scientific notation? Again, it's a notation. It's a way of writing down a number. Okay. It's a way of writing down a number. And notice here, shifting the comma. Right. Let me just do this thing with you people. We shifted this comma to the right once. This one over here, we shifted the comma to the left twice. Right. Okay. We shifted the comma to the left twice. Okay. Now remember, in terms of mathematics, if I were to shift the comma to the left effectively, it means that you actually divide by 10. If you shift it to the left twice, then you divide it by 10 squared or divided by 100. Right, can you see there? 22.5 divided by 100 will give you this answer, 0.225. Right, 16.2 multiplied by 10 by shifting the comma to the right will be 162. So keep this thing in mind. But shifting the comma to the left means dividing. And by 10 to the so many, however many times, right, you move to the left. If you shift the comma to the right, for however many, you will say times 10 to the this, times 10 to the that, and whatever, right? Like if you shift it to the right once, you multiply by 10 to the 1. If you shift it to the right twice, you multiply by 10 to the 2, right? Okay, so shifting the comma to the right means multiply by 10 to the so much, and shifting the comma to the left means dividing by 10 to the so much. Keep that in mind. Okay, now a number is represented in scientific notation when the decimal point is moved to the right of the first non-zero digit from the left of the number string. To represent the number in scientific notation requires moving the decimal point. Now let's see this example. Remember, we saw this example. If you want to write this thing in scientific notation, then that decimal, where's the first non-zero number from the left of the string? This is your string of numbers. So we want that point to be there, to the right of the first non-zero from the left of the string. Right, so 4, that dot must come here. Now, how do I get from here till there? I have to shift the comma, or the dot rather, decimal point. It's not a comma, please. Ne? People, please, it is not a comma. It is a dot. It's a decimal point. It's very important because sometimes the Americans, when they use a comma, they use that as a divider for thousands. Right, so we speak about a decimal point and not a decimal comma. I still make a mistake with that sometimes, but we should remember it is a decimal point. So the decimal point moves to the left how many times? 1, 2, 3. So if I shift it to the left times 3, then I've actually divided by 10 to the 3 to get it there. Right, but remember this number must still have the same value as it is here. Okay, it must still have the same value. So if I divide it by 1,000 to get there, but then I must multiply by 1,000 somewhere else so that the value can remain the same. In other words, I multiply this whole thing by 1. Anything multiplied by 1 will be the same number. 2 times 1 is 2. 10 times 1 is equal to 10, and so on and so forth. So this multiplied by 1 will give me the same value. But what we do is, let me show you here in the solution. There you have your number. You want to shift that to that point, eh? So we say there, you have to divide it by 10 to the 3, right? Divided by 1,000. But what I do is, I take this number, multiplied by 1. Can you see there? 1 can be represented by this. Because there, I know I must divide by 1,000. There, 10 to the 3, divide by that. but then I also multiply by 10 to the 1,000. So I do that, divided by 1,000, and I still have to show the multiply by 10 to the 1,000, so that if I have this here now, can you see this number divided by 1,000 will give me that? You see, there I've got the scientific notation, and then that one remains. There you are. So this number as you have here has exactly the same value as that number. So can you see the 4.321456 times 10 to the 3. So if you say times 10 to the 3, shift it to the right. 1, 2, 3. Can you see? Then that dot comes to where it was. Right. So that number can be written in scientific notation like this. And notice in your scientific notation, what do you have? You have a number with only one non-zero digit on the left of your decimal. And then you say times 10 to the whatever. However many times you shift your comma, that is what you're going to get there. Let's have a look at the next example, this one over here. Here you can see if you want this in scientific notation, then this decimal must come to the right of 2. So how many times do I shift it? I shift it to the right twice. 1, 2. And that means I had to multiply it by 100 to get that. But remember, if I multiply by 100, I must also divide by 100. Or you divide by 10 to the minus, you times 10 to the minus 2, I mean, right? So there you can see. There we are, times 1. I must multiply this by 10 to the 2. There we are. But because it's multiplied by 1, if you multiply by 10 to the 10 to the 2, you also divide by 10 to the 2. There you are. So you multiply that in there to get 2.406. There you are. Multiply that in there, but then you must also divide by 10 to the 2. Right, but we don't write divide by 10 to the 2. We say multiply by 10 to the minus 2. So this number, 0.02406, can also be written as 2.406 times 10 to the minus 2. Okay, scientific notation. A matter of interest, on your calculator, I'm using Casio here because I know most of the students have Casio calculators nowadays. Right. How can you get this into scientific notation very quickly? There I'm showing you the principle of how to do it. If you do it on a calculator, please, people, you can use this thing, but make sure you understand it as well. Try to do it by hand, and then you can check it on the calculator. So what do you do? For you to be able to do this, you can actually get it into scientific notation. Then you say there, you go into the calculator, you can see here, there's something, there's a shift setup there on top, shift, and there's setup. So you press shift, setup, like that, and then this appears. Now you have an option. You want scientific notation, there it is, SCI. Then you press 7, you select 7, press that, and then once you press that, and then they must say you must select a number from 0 to 9. This is just to indicate how many numbers you want in your string. Okay, how many numbers you want in your string. Where is that? Did I do it? You will actually see if whatever number you use here, it will tell you how many numbers you have in your string. At the moment here you have, for example, here 2, 4, 0, 6. This is 1, 2, 3, 4. So if I were to say here, shift, setup, 7, and then you press 4, then you'll get the number written down just like that. If you want to say, again, shift, setup, 7, 2, then it will, this number will be written as 2.4. It rounded that off so that you only have 2 digits shown. And if you have 8, then it would have been, let's say 8. If you had to press in 8, that number 8 there, it would have given you this number 2. It will still be scientific. 0.406. How many do I have so far? 1, 2, 3, 4. So I must add another 4 zeros. Right, and then it will still be times 10 to the same thing there, minus 2. That's your scientific notation. For if you had to press 8 and 8 in this selection over here. The 1 0 here doesn't mean nothing. It actually means 10. Right? This one actually means 10. Right? 10. So you would have had 1, 2, 3, 4, 5, 6, 7, 8, and another 2 zeros if you had to choose the 0. Okay, so that is how to get it onto the calculator, get the answer on a calculator. Okay, right. Next thing that we can speak about is engineering notation. Engineering notation. In engineering notation, we're going to use other prefixes. This what we had here is what we call the metric, right? Just from, can you see, standard form up to kilo, from standard form up to milli. Now from standard, if you ignore the deca and the hecto, or the deci and the centi, you move from here to there. Then you can see from standard form to kilo, it's 1,000, a factor of 1,000. Or from standard form to milli, will also be a factor of 1,000. Here you divide by 10 to the minus 3, and this way you multiply by 10 to the 3. Okay, so in engineering notation, what we have here is we have these prefixes that we have here. It will always involve a factor of 1,000, not a factor of 10 as we have here, a factor of 1,000. Okay, let's get there quickly. So there we have examples there, right? I can show you in the table. Those are your engineering notation prefixes. Normally we would, at school, they only go up to from pico to milli, and from kilo to, I think, to peta. Not peta, no, don't get hungry now, peta. Okay, so, but yeah, they have even further, up to from 10 to the minus 24 up to 10 to the 24. Right. That's some extra things to remember, but it's worth your while getting to know them. We don't give these things in the exam, so please, people, get to know them. Right? Get to know them. Right? Okay, if I say I have a picometer, then it will be involving a multiplication factor of that. Can you see here? Just notice here. 10 to the minus 3, minus 6, minus 9, minus 12, minus 15. Can you see? That's like a multiples of 3. And these one also, can you see there? 3, 6, 9, 12, 15, multiples of 3. So 10 to the 3, 10 to the 6. You can see every time it's 1,000. Right. Okay, so if you have a kilo something, then it will be considering that. If you have a nano something, it will be 10 to the minus 9 of it, and so on and so forth. Okay, so similar to what we had in this table, the conversions, this table over here, we do similar conversions in engineering notation, but then you have to use these prefixes. Standard form again has nothing, right? But all the others, it will give you prefixes of factors of 1,000 or so. You can see always 10 to the, this number will always be a multiple of 3. Then you know you have something in engineering notation. Take this example here, for example, that there, can you see there, minus 2? That is not an engineering notation. I can see immediately that this is not an engineering notation because that 2 is not a multiple of 3. In the other example that we did here, this one, this is an engineering notation because, can you see there, that exponent over there is a multiple of 3. So this, as it is here, it is in scientific notation, but it is also an engineering notation because of that. Okay, the exponent of 10 must be a multiple of 3. Okay. Okay, so you can see here the conversion methods. Again, if you want to convert from standard form to one of the other prefixes, you divide by the multiplication factor. You need to know these multiplication factors, please. When you want to convert from another prefix to the standard form, then you multiply by the multiplication factor. And when you want to convert from one engineering notation to the other engineering notation, from one prefix to another prefix, first convert it to the standard form, and then from the standard form to the next one. Here are some examples. 2.5 meters converted to millimeters. So that is, can you see the meters? That is standard form. Millimeters, that will be a prefix, milli. Right? So you look at the conversion factor for this one over here. That is milli, so that means times 10 to the minus 3. Or if you want to convert, so you have to divide by 10 to the minus 3. Right, divide by 10 to the minus 3 means multiplied by 10 to the 3. So 2.5 meters would be 2.5 times 10 to the 3 millimeters. And there's the answer if you multiply it out. Convert from grams to kilograms. Grams is standard form. So from grams to kilograms, that is again standard form to a prefix. You have to again divide by the conversion factor. Kilo is times as 10 to the 3. So you have to have this and divide it by 10 to the 3, and there's your answer. Convert from mega ohms to kilo ohms. What can we do here? First, convert from mega ohms. If you know what the answer is, the conversion between mega and kilo, which is 1,000, then you can work it out. Alternatively, convert from mega ohms to ohms first, standard form. And then from standard form, as you have here, from standard form, you convert it to kilo ohms. And you can get the answer over there. Okay. Right. What do we have here? We've got the two same numbers here. Convert these two numbers in scientific notation. Sorry, this I should have written here. This is a mistake here. That should be engineering. No, I'm sorry for that. I just copied and pasted. That should be engineering. Please correct that. I'll correct that in my notes and then repost. But in the meantime, if I don't, please just say the engineering notation. So what do we do? The first one, okay, that was the case already, right? There you can see that one over there. E is equal to that. So that is how many meters? See, 4.32 ... meters. Right, you can see meters and meters. Both of them are the same. But now if you want to write it differently now, if you say times 10 to the 3 meters, then I know times 10 to the 3 means kilo. Right, then I can write that down as 4.321456 kilometers. You can leave it like this in meters, or you can write it down like that if they ask you for the answer in kilometers. All right. First convert it to meters according to engineering notation, and then based on the prefix, the 10 to the 3, that multiple, you can write down what prefix you are going to use. Okay. If you wanted another, for engineering notation, I wonder now, just to show you another thing, if I wanted to, I could have done it another engineering notation. What I did here, I moved this thing to the left, right? I moved this thing to the left to get it into kilo, right? For that example over there. But I can actually move it to the right as well 3 times. And that will also give me an engineering notation, right? Okay, and notice, I'll talk about this thing again. I kept my decimal point there. Right, I kept my decimal point there. Even though I have nothing on the right-hand side of it, I keep it there. There's a very important reason. I'll talk about that in the next session. So there you are. If I move this thing to the right 3 times, then it means effectively times 10 to the minus 3. Right, remember, to the right means times 10 to the 3, but to get that the same value, I must also divide it by 10 to the 3. Right, that's why I said times 10 to the minus 3 written. But now, can you see there? That number times 10 to the minus 3. 10 to the minus 3 means milli. That means millimeters. So many meters would be equal to so many millimeters. Oh, there should be a dot there. I forgot. There, I left it out. That dot should be there. Okay, let's look at the next example. The decimal point. In this case over here. Well, I can move further to the left, but I think here it will be better to move it to the right. But remember, this thing is in, where's the value? I gave it to you, kilograms. All right? It is in kilograms. You want to write that in an engineering notation form. Remember, as it is in kilograms, that is already an engineering notation. But if you want to write it in a simpler form, you can actually go and write it in grams. Grams is also an engineering notation, 10 to the 0, right? And 0 in that case is also a multiple of 3. So you move this thing to the right 3 times, 1, 2, 3, then you will get 24.06. If you move it to the right 3 times, multiply by 10 to the 3, then you say, if you multiply by 10 to the 3 to get this, then you must also divide by 10 to the 3. So that you can have the same value. So this here, kilograms will be so many grams. You see that we wrote it down as so many kilograms, and then I remove nothing there to get it into grams. Okay. Yeah. Okay. Now another way in which you can do this thing is to do it on a calculator. Again, I'm using the Casio. If you have that number, press in that number, press equal to. Right, and you get this. Right, if you just press in the number, it says there, and don't press equal to, then there will be nothing here, and it's not going to work. First, get that number and press equal to. Right, if you now want to convert this number to engineering notation, it's a very simple exercise, people. We just press eng. Eng. Can you see the ENG? Just press that. Once you have it there, you just press eng. Then it will give you your engineering notation. You see that number is the same as the number that we had there. Okay, there you are. If you want to, if you press that again, eng, if you press it again, then it gives it to you in another way, but also engineering notation. You will always see times 10 to the something with a multiple of 3. Press it eng, you get different engineering notations of the same number. And the other one, 0.02406, press equal to, then you get it there. And then you press eng, then you can get that answer there. Can you see it? That answer is the same as the answer that we had here. Okay, there you are. Okay, just so you want to use a calculator, right? That is to make life easier for yourself. But again, I'm going through it like this here so that you can appreciate where it actually comes from. Okay, there are a few conversion factors that I wrote down here. You people can try to remember those things as well. I'm going to stop here, and this is going to be an extremely important discussion in part 4. Thank you very much, students. Bye.